Let's start with the response cache control directives. They are what we've been seeing on the slides up until now, and they are set by the server. The first two have to do with how long a response can be considered fresh. Max age defines the maximum age after which a response expires in seconds. S max age overrides the max age value for shared caches. So a response can expire differently in a private cache versus in a shared cache. Then we have two that relate to the cache type or cache location. Public indicates that a response may be cached by any cache, private or shared. Private indicates that all or parts of the response message are intended for a single user and thus must not be cached by a shared cache. And then there's three that relate to validation. No cache indicates that the response should not be used for subsequent requests without successful revalidation with the origin server. Two more directives have to do with that: must revalidate and proxy revalidate. With must revalidate, the server can state that if a response becomes stale, then revalidation has to happen. This is to allow the server to force revalidation by the cache even if a client has decided that stale responses are okay. And proxy revalidate is exactly the same as must revalidate, but it doesn't apply to private user agent caches like a browser cache. Lastly, there is no store and no transform. No store is available at client level as well, and it states that the cache must not store any part of the message. It's mostly used for confidentiality reasons. No transform states that the cache shouldn't convert the media type of the response body. Now, all of these are decided on by the server, but the client can override some of these settings, or rather use the same directives to tell the cache or the server what it is willing to accept. But the client can override some of these settings, or in better wording, use the same directives to tell the shared cache or API server what it is willing to accept. In regards to freshness, max age indicates that the client is willing to accept a response whose age is no greater than the specified time in seconds. Min fresh indicates that the client is willing to accept a response whose freshness lifetime is no less than its current age plus the specified time in seconds. That is, the client wants a response that will still be fresh for at least the specified number of seconds. And max stale indicates that the client is willing to accept a response that has exceeded its expiration time. This is the one must revalidate in the response reacts against. By the way, when I say client here, I am always talking about the component that sends the request. There's only one related to validation, and that's the no cache directive, stating that the response to this request should not be used for subsequent requests without successful revalidation with the origin server. In other words, with the API. No store and no transform are the same as for response headers. There's only one new one, only if cached. This states that a client wants the cache to return only those responses that it currently has stored and not reload or revalidate with the origin server. This one is typically used when there's a very poor network connection. These are already pretty advanced directives and options. In a lot of cases, we're quite okay with just using max age and public or private. In the next module, we will dive deeper into caching. For now, it is time for the summary. We started learning about caching in this module. One of the REST constraints is that each response must state whether or not it can be cached. We looked into the HTTP caching standard, and that was a lot of information. Caching really isn't a simple subject. But the important parts are to remember that the cache itself can be private or shared, and depending on the type, a model can reduce bandwidth requirements and/or network round trips. These models are the expiration and validation models. We use the expiration model to allow the server to state how long a response is considered fresh. For that, we use the cache control header. The validation model is used to validate the freshness of a response that has been cached. It does this with the help of strong validators like ETAGs or weak validators like last modified dates or weak ETAGs. The response caching attribute is used to control the cache control headers on the response message. The response caching middleware acts as a cache store. It's this component that effectively stores the responses and potentially serves them up from the cache. But that attribute has limitations. It cannot generate strong validators like an ETAG, which limits what we can do with it. And the cache store has some limitations as well. In the next module, we'll solve these issues. ETAGs are strong validators that improve the reliability of the cache validation model. In this module, you will learn how to use those, amongst other things. I'm Kevin and I'll guide you through it. We learned that the response caching middleware isn't bad, but it also has its shortcomings. In this module, we will learn how to circumvent that by learning how to work with ETAGs. We will learn how to do that with global configuration and resource level configuration. We will also look into cache stores and CDNs, or content delivery networks. We will end the module by looking at cache invalidation. All of this will lead to full support for HTTP cache for our API. As we learned in the previous module, the validation model requires a validator. Dates are weak validators, ETAGs are strong validators. Such a strong validator is preferred over a weak one. The response cache attribute doesn't generate those, so we need another component that will. To make our lives a bit easier, I created such a component. It's named marvin.cache.headers. You can find it on NuGet and on GitHub. It's a piece of ASP.NET Core middleware that adds HTTP cache-related headers to HTTP responses, like cache control, expires, ETAG, and last modified. It also implements cache expiration and validation models, just as we learned in the previous module. So it can be used to ensure that caches correctly cache responses and or to implement concurrency for REST-based APIs using ETAGs. Concurrency is covered in the next module. It's important to know that the middleware itself does not store responses. I wanted to create something lightweight that could easily be plugged into the request pipeline with a pretty narrow focus, correctly generating the headers so a cache can check for expiration, which is a 304 not modified, and preconditions, which is a 412 precondition failed. The last one is often used for concurrency checks. Let's start by adding this piece of middleware to our project to generate ETAGs. In this demo, we will add support for generating ETAGs. The first thing we'll need to do is add the middleware to generate these. So let's open the NuGet dialog and let's browse for marvin.cache.headers. And let's add the latest version. Alright, so far for that. Let's switch to the configure services method on our startup helper extensions. And let's register the required services on our container. There we go. This is also where we can configure options for how these headers are generated. For now, we will leave everything at its default. In the configure method, we add the middleware to the request pipeline. The order in which we add this is important. We want to add it before the controller middleware, as in some cases, this middleware must ensure that the request pipeline doesn't continue to that. For example, when validating that a response is still valid even after it has expired. In that case, 304 not modified should be returned, and the response body should not be regenerated. In other words, in that case, the headers middleware must stop that middleware from executing. Next to that, it should be added after the cache store, so after use response caching in this example. When an item can be served from the cache, the eTag generating middleware should not be executed. That's it as far as code is concerned for now. We'll test this by getting a course for an author. However, currently we still have these response cache attributes applied here. Let's comment that out. And let's also comment out the response cache attribute at controller level. All headers will thus be generated by the marvin.cache.headers middleware from now on. Let's build and run this. We've still got a request to get a course lined up here from the previous module. Let's send that again. We get back a response. And if you look at the response headers, we see that a cache control header has been added. The first value is public, which states that the response can be cached by shared and private caches. It also states that the response is valid for 60 seconds via max age. The expires header also reflects this. It expires 1 minute from now. So both these headers are added, but as we learned, using the cache control header is advised, so that's what we'll focus on. Next to that, validation-related headers have been added as well. A strong eTag has been generated, and a last modified date, which is the current date, has been added as well. Same logic applies here. We learned that using the eTag is advised over using the last modified date. So that's what we'll do. How eTags should be generated isn't part of the standard. It's up to the server, to us, to decide on this. And that makes sense, as it is only us who can decide when a response should be considered equal or equivalent. By default, the middleware takes the request path, accept and accept language request headers into account, and the response body. That means that when an update to a resource happens, the generated eTag will be different. That will come in handy later on. If that isn't sufficient for your use case, you can inject your own service to generate eTags if you wish. Let's have a look at the console output window. We can see that quite a bit of information related to these headers is outputted. Like that, you can easily see what's going on. Let's send this request again. And once more, because I talked more than 60 seconds. There we go. We now see that we get back a response with an age header. That already leads us to thinking that this response is probably being served up from the cache. And if we have a look at the console output window, we see that the expiration and validation related headers have been generated once, but not twice in a row. So indeed, the last time we sent the request, the cache headers middleware wasn't hit, meaning our request was served up from the cache. Let's learn how we can configure expiration and validation model options next.